See, I was saying that resistivity, right? So resistance is R is equal to rho L by A. Therefore, resistivity will be rho is equal to R A into by L. Now, there is a statement at times given. What do you mean by the statement that the resistivity of copper is 1.69 into 10 to the power minus 8 ohm meter, right? In this formula, rho is equal to R into A by L. If I take A 1 unit, L 1 unit, rho becomes R. It means that a rod of copper of 1 meter long, 1 unit means 1 meter long, and having cross sectional area 1 meter square has a resistance equal to 1.69, because here here R will be rho L by A, right? So put 1.69 into 10 to the power minus 8, right? And into 1 by 1. So this will be what? Chalo. This is meter square. No, sorry, meter. And this is meter square, but this is in ohm meter. See, everything will be cancelled. Don't worry. Ohm meter. Meter square cancelled. So we get how much resistance of copper? Of 1 meter long rod, and the cross sectional area of the rod is 1 meter square. Then it has a resistance equal to 1.69 into 10 to the power minus 8 ohm. Can you see, if the resistivity is low, the resistance is also low? Clear? It has been found that metals, see, lowest resistivity is platinum. Clear? Now, since the resistivity is low, in our household wiring, what I was talking about, household wiring means whatever wiring is done in our house. Earlier it used to be copper. Now copper is also too costly. So they do it by aluminium. But wherever the quality has not to be compromised, we use copper only. Now there could be a question. Why silver is not used though its resistivity is too low? Answer is nothing. Answer is not cost effective. It will not be cost effective. It's costly, na?
Yes.
See, if you have a flat of say 1500 meter square, right? Say 1600 meter square, right? So at least if I make it a room, 1600 meter square means, suppose this is the flat. So this is 40 meter or not? This is also 40 meter. I made it a
Yeah.
squarish. So how much meter of silver wire you will require? 160 meter, right? 160
Yeah.
meter. 160 meter means 160, and then thickness of the wire, if I multiply, say thickness is 0.25. So this becomes 4 and 40 meter cube. Now multiply by density, you will get the mass. Silver's density is also very high, right?
Yes, sir.
If I multiply by the density, I'll get the mass. Now, can you see that much gram or that much kilogram? It will come into kilogram, right? You can find the daily silver rates on the net. So that is why we don't use silver. Though silver will act more effectively, but wherever quality is a question, not quantity. Wherever we cannot compromise with quality, we not only use silver, we also use platinum in some most sensitive devices. Is that clear?
Yeah,
Achha. Now, note it down fast.
noted.
Noted. Okay, good. Now, resistivity of alloys. The resistivity of alloys are very high. Okay. Now I'll name two alloys. Manganese. Manganese. It's an alloy of copper, manganese, and nickel. Alloy of copper, manganese, and nickel. Right? Has high resistivity. Has how much high? Resistivity equal to 20 times resistivity of copper. See, we have another alloy called nichrome. Alloy of obviously nickel is there. Let me see. Nickel and then chromium, I think it is there. Chromium's. What is the symbol for chromium? Cr or CH? CH, na?
CH, I guess.
Oh, okay, okay. So nickel plus CH plus manganese plus Fe.
So it is CR.
I had a doubt earlier. See, yeah, okay. Has resistivity equal to almost 60 times more than resistivity of copper, right? Now we use some heating appliances, right? Use of nichrome as an heating element, heating element. Beta, you have seen the room heater somewhere?
Which one?
Room heater, room heater.
Yes.
Kolkata, we don't have room heater. But if you go out means go to the colder side of the country, you will find room heaters. So element means coil. The spiral coils are there, right? Of heating appliances, appliances as geyser, geyser, iron, electric iron, toaster, electric kettle, etc. Why? There are two reasons. First, nichrome has high resistivity, which produces high resistance and this high resistance produces of produces a lot of heat when current passes through through it. Is that clear?
Yes, sir.
Now suppose this is a nichrome coil. Okay. It has a high resistance. Clear? Now if
Yeah.
I pass a current, right, it will produce heat.
Yes.
Clear?
Yes, sir.
Now if I want more heat, I can increase the current.
Yeah.
We have studied,
So,
no? Yeah. If I increase the current, it will produce more resistance to the current, and hence it will produce more heat, and finally it will melt or not.
yeah, the coil will get overheated.
So that is why we don't use copper in room heater.
So they
See
have a high melting
what is
point.
burning? What is burning reaction? Chemistry, in chemistry, what do we call it? Oxidation, na?
Yeah.
Nichrome does not undergo oxidation even at high temperatures, and thus it does not melt or burn easily.
Written, sir.
Written? Okay. Now we'll go for conductivity, which we were supposed to start. I'm mentally not well today. Okay. Now let's go conductivity. Conductivity. Right? This is not in your syllabus. It is denoted by something like this to be read as sigma. And conductivity is very easy. Definition: conductivity of a conductor is the reciprocal of its resistivity. Therefore, sigma is 1 upon rho. Now, SI unit. See, we know the unit of resistivity, which is ohm meter. So it will be ohm inverse meter inverse. This ohm inverse has been given a name SIE Siemens meter inverse. In short, we write SIM inverse. Earlier, we used to use, this is discarded now. What is the spelling of ohm? OHM. We used to write it MHO. I have read this unit. When I was young, this unit was in practice. So we used to write meter minus 1. Now this is no more in use. Okay. Noted?
No, sir, 1 second.
Done?
Yes, sir.
Okay. Now let's do some numericals based on resistivity. So I'm taking NCRT examples. Later on, we'll be doing better questions also. Some standard. So numericals. Number one, question one. A copper wire of length 2 meter and area of cross section, area of cross section 1.7 into 10 to the power minus 6 meter square has a has a resistance of 2 into 10 to the power minus 7 ohm. Find its resistivity. Gauri done?
Yes, I'm doing the calculation.
It is based on formula, just direct formula. Not to worry about anything. But I'll be back from washroom. No, Gauri, power is wrong. There's something wrong. See, we do these questions like this. Given L is equal to 2 meter. A is equal to 1.7 into 10 to the power minus 6 meter square. R is equal to 2 into 10 to the power minus 7 ohm. So R is equal to rho L by A. So rho is equal to R multiplied by A divided by L. Put the values 2 into 10 to the power minus 7. A 1.7 into 10 to the power minus 6, right? By L. That is, Acha, I have written mine minus. This was minus 2. Anyway, your answer is correct. Your answer is correct, 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 correct. If it is given like that, so what can you? It was minus 2, right? And divided by 2. So this becomes 1.7. Correct. I have corrected the question. The correct answer will be then in that case 10 to the power minus 8 ohm. No, your answer is right, Gauri. Okay. As per the
Okay.
given thing, answer is right. Now go for the question number 2. A copper wire has a diameter is equal to 0.5 millimeter mm, and resistivity resistivity of 1.6 into 10 to the power minus 8 ohm meter. Now there are two subparts in this question. A, what will be the length? What will be the length of this wire to make a resistance 10 ohm? To make a resistance 10 ohm, how much does the how much does the resistance change? The resistance change if the diameter is doubled. হ্যাঁ স্যার, আপনি ভালো আছেন তো? হ্যাঁ, হ্যাঁ, হ্যাঁ। আচ্ছা, সেই জন্য কালকে ম্যাডাম বললেন, আসলে আমি কালকে আর আপনাকে ডিস্টার্ব করতে চাইনি। আমি ম্যাডামকে ফোন করেছিলাম, তো ম্যাডাম বললেন যে শোনা যাচ্ছে না আপনার কথা, আমি ট্রেন থেকে নেমে ফোন করছি। যাই হোক, যে কোনো কারণে তারপরে ম্যাডাম কিন্তু কল ব্যাক করলেন না রাত্রেবেলায়। আমি একটু চিন্তায় পড়ে গেলাম। স্যারের কি হলো রে বাবা। আর আর এই বৈদুর্যটা এত বোকা যে ও জানে না আপনার ইসিজি চলছে নিচে, বলছে বাবা নিচে আছে। আচ্ছা, তো আপনারা ফিরছেন কবে? হুম। আজকালকার বাচ্চারা ওরকম। হুম। স্যার, আমি আমি একটা সাজেশন দেবো স্যার আপনাকে। এখন দিন সাতেক না টুরিং মারবেন না স্যার। আজকে সাথীর জন্মদিন। আজকে আমার মন খুব খারাপ। তো স্যার, আমার রিকোয়েস্ট এটা, পারলে আপনারা বসিরহাটেই থাকুন এখন কিছুদিন। আপনি জার্নি করে আসবেন অতটা। আচ্ছা। হুম। ওকে। আচ্ছা। হুম। 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 তা ওরা ডাক্তার থেকে বেশি বোঝে। যদি যদি সিনিয়র টেকনিশিয়ান হয় না, ওরা ডাক্তার থেকে বেশি বোঝে কিন্তু। হুম। 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 আচ্ছা। স্যার, আপনারা ফেরত কলকাতা চলে আসছেন না কেন? আপনারা ফেরত কলকাতা চলে আসছেন না কেন? আপনারা চলে এসেছেন? আপনি কি কলকাতায় এখন? বসিরহাটে? হ্যাঁ। হুম। 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 না, না, সেটা ঠিক আছে, কিন্তু আপনার কার্ডিওলজিস্টটাকে দেখানোর ব্যাপারটা কি ডিসাইড করছে? ওটা বেশি ইম্পর্টেন্ট স্যার। হুম। 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 হ্যাঁ হ্যাঁ ওনার কাছেই জানেন, উনি দেখেছেন আগে। গ্যাস্ট্রোএন্টারোলজিস্ট। হুম। কনস্টিপেশন আছে নাকি স্যার? কনস্টিপেশন আছে? আপনি ডিউফেলাক এম মিউকেন জেল। না বেশি খাবেন না। কেন? না খেলে কি হয়? হ্যাঁ 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 হ্যাঁ। আচ্ছা আচ্ছা আচ্ছা। হ্যাঁ। আচ্ছা আচ্ছা আচ্ছা। না আপনি কার্ডিওলজিস্ট ইমিডিয়েটলি দেখিয়ে নিন স্যার। আর এখন একটু না, এখন ইসিজি তে যে যে গন্ডগোলটা পাওয়া গেছে সেটা একটু দেখিয়ে নিন না, বেটার হবে। কেন রিস্ক নিতে? দেখুন স্যার, আপনি বেশিরভাগ সময় বাইরে থাকেন, বুঝতে পেরেছেন তো? হঠাৎ কোনো এমার্জেন্সি হলে তখন আপনাকে দেখার কেউ থাকবে না ওই সময়। আর আজকে আমি আপনাকে মেসেজ করলাম, আপনি রিপ্লাই করলেন না, তখন আমি আরো চিন্তায় পড়ে গেলাম যে কি হলো। আচ্ছা 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 আচ্ছা। না না, শুয়ে থাকুন, শুয়ে থাকুন, রেস্ট করুন। ওকে স্যার, ওকে স্যার, ওকে। সরি ফর দ্য ইন্টারাপশন, গৌরী। Gauri, are you there?
Yes, sir.
Done?
Yeah, the first part is done.
Yeah. Okay, the first part is done. What is the diameter? 0.5 millimeter. Okay, 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 okay. How much will be the length required? But how you have done this question, I am not able to understand. What is your answer for A? Sub part A?
One, 12.5 into 10 to the power 4.
Hmm, okay, let's solve it. Given rho is equal to, let me cross check if I have written it correctly, 1.6 into 10 to the power minus 8 ohm meter, right? Resistance, sorry, resistance, radius R is equal to diameter by 2, that is 0.5 by 2 into 10 to the power minus 3 meter, because it is in millimeter, right? And R is given we need a resistance of 10 ohm. 10. So R is equal to rho L by A. Now we have to calculate A. A will be pi R square. This is a wire. Radius is given. So it will be 22 by 7 into 0.5 by 2 into 0.5 by 2 into 10 to the power minus 3 into 10 to the power minus, right? So let's calculate 5 5s are 25. Let's do one thing. 22 by 7 into 2 into 2 into 25 into 10 to the power minus 2 into 10 to the power minus 3 into 10 to the power minus 3. So it will be 2 11s are 11 into 25 by 14. 11 into 25 by 14 into 10 to the power minus 8. This is my area. I will not go for simplification here. Now let's put, they have asked resistance as 10 ohm. Resistivity they have given 1.6 into 10 to the power minus 8, right? L is given, no, length is required. Length is required and area. So we can multiply area here. So area we have got 11 into 25 by 14 into 10 to the power minus 8 is equal to 1.6 into 10 to the power minus 8 L. Corey, any problem in understanding this? How, what I am doing?
No, sir.
Are you clear? I multiplied this resistance with the area. Is it okay? Then into area, I have got this much, right? Is equal to 1.68 into L.
Yes.
Okay. Now see, 10 to the power minus 8, 10 to the power minus 8 cancelled. Right? So we have 25 ones are 25, 25 ones are, oh, okay, yeah. 25 ones are 25, 25 ones are 25 and 2, 275. Clear? Multiplied by 10 is this, by 14 is equal to 1.6 L. Now L will be equal to 2750 divided by 14 into 1.6. Okay, calculate this. Your answer is too high.
It is 12.27.
It should be 122.27. It is 2750. So this will
That
be
is 1 point.
27500
So it is
64.
122.76.
Now if I divide, it should come close to 122.7 meter. Just check.
Is 122.27.
122.27.
One.
Yeah, let's do it. 224 27500. Ones are 224 150 448 2 2 10 minus 4 is 6 620. It will not go 3 times, it will go 2 times. So again 448. 10 minus 8 is 2. 11 minus 4 is 7. 11 minus 4 is 7. And 5 minus 4 is 1. Now point 0. Now, if I multiply it by 8, what will happen? 8 4s are 32. 8 2s are 16 and 3 19. Right? So it will become 1792. So I can go for 7 only. Right? 7, 7 4s are 28. 7 2s are 14 and 2 16. 7 2s are 14 and 1 15. You want to go for 2 decimal places, you can go once more. 10 minus 8 is 2. 11 minus 6 is 5. 6 minus 5 is 1. 1520. 1520. So it will go 6 times. 7 times it will not go. 122.76 meter. Right? Clear?
Yes, sir.
Okay. Now in subpart B they have asked. In subpart B they have asked if the diameter is doubled. How much change would be there if the diameter is doubled? It was not a numerical, it was basically a conceptual thing. See, R is equal to rho L by A. Am I right?
Yes.
That means R is equal to rho L by pi R square, in this case, area.
Yeah.
So R is, see, pi is a constant.
Yes.
Pi is a constant and rho will be constant for copper,
Yeah.
and we are not changing the length. We are not changing the length. So length is also constant. That means R is directly is inversely proportional to R square or not. Suppose the initial resistances are initial, right? Say is equal to K by R square. Now what we are doing? R final. We are making R dash. R dash is equal to 2R. We are doubling the diameter, so radius will be also doubled or not.
Yes.
So 2R whole square. Clear? That means Ri by Rs is equal to K by R square. K I have just taken a proportionality constant, nothing else. By See, if we take this rho L pi as K, can I write R is equal to K R square, K by R square?
Yes, sir.
Okay. So it becomes K by 4R square. So Ri by Rf will become K cancelled 4R square upon R square. Again R square cancelled. So Ri is 4 times of R final. But they have asked R final will be 1 upon 4 times R initial. That means 1 by 4 into how much resistance was given? 10 ohm. That is 2.5 ohm. Is this absolutely clear now?
Yeah.
Okay. Wait a minute, because I have to get this flow. We'll go for one more question and then we'll go for combination of resistances in series, in parallel. The derivation is also asked in boards. Derive an expression for 3 different resistances connected in series. Okay, question number 3. A 6 ohm resistance resistance wire is doubled doubled up by folding by folding. Calculate the new resistance of wire. Suppose this is the wire, okay. Now they have doubled it up by folding. So it is looking something like this. What has increased, Gauri?
So double by folding means only the length will get doubled.
No, Gauri, length will get half. Cross-sectional area will go double. Shall I do it?
No, I got it. Sent so.
Gauri, have you sent? Let me
Yeah.
check. Good, correct. See, R1 is what? R1 is equal to rho L1 upon A1, right? Now, here we will write L2 is L1 by 2. If this is L1, so this will be L1 by 2. And A2 will be twice of A1. So R2 is equal to rho L2 by A2 is equal to rho L2 is L1 by 2 and this will be 2A1. So this will be rho L1 by 4A1. Now R1 by R2 is equal to rho L1 upon A1 by rho L1 upon 4A1. A1 cancelled, L1 A1 L1 A1 cancelled. This 4 goes on the top, so it becomes 4. Therefore, R2 is equal to R1 upon 4, that is 6 ohm upon 4, that is 1.5. Right? You could have taken only L also. That is not necessary. Right?
Yes, sir.
Okay. Now let's go to the combination of resistance. We can combine resistance in two ways. This is the most important part of the chapter. This chapter will be full of numericals. So we are starting combination of resistors. Combination of resistors or resistances. See, we have two type of combinations. One is called series. Suppose this is one R1 resistance. It is directly connected like this with R2. So this is called series combination where head of a resistance is connected to the tail of the other resistance. Second is parallel combination where all resistances, suppose this is R1, R1 and this is R2 and this is R3. So all tails connected together, all heads connected together. Clear? Is this clear?
Yeah.
Okay. Now we will find out what is the equivalent resistance of a series combination. So we will go for first for series combination. Listen to me properly. I am going to make a circuit. Suppose I have three resistances. One is R1, one is R2, and one is R3. Is it clear up to this?
Yes.
This is your R1, this is R2, and this is R3. Let us connect them with a cell. Clear? Which has a
Yeah.
potential difference V or potential V. Now the current I, some current I will flow like this, positive to negative. You can use a switch
Yeah.
also if required. We can show a key also, key closed. Now the same current I has to go here. Here also, if we apply an ammeter, we'll find I. So the current I is emerging out of positive terminal and then again getting back as I. So I remains same. In a series combination, the current through each resistance remains same. Clear?
Yes, sir.
Okay. Now, if this has a potential difference of V, there will be a potential difference of V here. Beta, what is V? According to Ohm's law, it is IR or not?
Yeah.
Suppose it is giving you 10 volts. Okay. Suppose it is giving you 10 volts. The battery is giving 10 volts. And the current is, say, 1 ampere. Okay. And value of R1 is 2 ohm. So how much? How much V will be dropped at 1? 2 volt or not?
Yes.
Now, suppose this is Suppose at this point, we found a drop of V1, right? Like this. Now, if R2, say it is 3 ohms. For example, we have taken 3 ohms. So it will be 1 into 3 or not. So it will be 3 volts.
Yeah.
So this potential will be V2. V2 and say V3 is equal to, suppose this is 5 ohm, 2 ohm, 3 ohm, 5 ohm. So here 1 into 5, that is 5 volts. So V3 becomes 5 volts or not?
Yes, sir.
Now add it up, 5, 3, 8 and 2, how much?
10.
So I have told you that it was giving 10 volts, na? Is
Yes.
that clear? That means in general, now I'm not taking any value. We can't take any values, right? It was just to explain you. I'll be drawing this circuit once again. This is R1, this is R2, and this is R3, right? This is the cell which is giving voltage V. Current I is constant in the circuit. I'm not showing the, chalo, I'll show the switch also.
So the
I,
voltage is like the potential difference that is going on inside the cell only, no?
yeah, potential difference in the inside the cell.
Okay.
Because of that potential difference, the current flows, na?
Yeah, so the value will be same.
No, here the voltage will drop
Why?
because this resistance will eat up some voltage. It has already 2 volts. Clear? If I apply,
No, like
wait a minute, wait a minute, wait a minute, wait a minute. If I apply a voltmeter here, right, it will show me 8 volts because 2 volts is already dropped as V1. That is called voltage drop, potential drop. Where is your uneasiness? Tell me.
no, like if a cell has say 20 volts, so the net
Okay.
voltage of the entire circuit will be 20 volt only.
Yeah, definitely. That is what I showed you. I added up and I got the 10 volts now,
Yeah.
but it is splitted now. In
Okay.
this case, the splitting will not be done. What is happening? Each resistance is eating up some voltage. Getting my point?
Yes, sir.
And that is, we don't call eating up. We call it potential drop. Some potential is dropped across here also, which will be V2. No, I forgot to write R1, R2, R3. And some potential will be dropped across this V3. Clear?
Yes, sir.
Okay. But there are two conditions. V is equal to V1 plus V2 plus V3, which we found here. See, 5, 3, 2, 10. And this was giving 10. This you were talking about, the potential difference will be here. If I apply a voltmeter, suppose I have applied a voltmeter, here it will show 10 volts. But separately, if I apply voltmeter in this, so that will show you 2, 3, and 5 consecutive.
So if
Is
I
that
like
clear?
put a voltmeter around a bulb in the circuit, So there will be a potential drop there also.
Yeah, definitely.
Okay.
Obviously. The potential is dropping, definitely. But if you add those potential drops, it is equal to the electromotive force, EMF. You will learn later. EMF is nothing but a potential difference across a cell. Across a cell when it is in open condition. Open condition means it is not connected to a circuit. Now see, here from here, can we write V is equal to V1 plus V2 plus V3? Can I write?
Yeah.
Okay. Now, what will be the value of V1 beta? Let's do it in rough. Using Ohm's law. I is say, don't you think it will be IR1?
Yes.
Similarly, V2 will be what? IR2.
IR2.
V3 will be what? IR3.
So I common R1 plus R2 plus
Now,
R3.
this is equivalent voltage, na?
Yeah.
So, this can we write R equivalent? Acha, acha. Wait a minute,
Yes.
wait a minute. Wait a minute. In place, I am making this circuit. Beta, this is 10 ohm. This is 10 volt.
So
Right?
current is 1.
Current is 1. You will be clear right now. Acha. Can I write now I R1? Acha. R equivalent, in place of R equivalent, we use RF. RF means R series. IRF is equal to IR1 plus IR2 plus IR3. And I have taken the values of V1, V2, V3 from here. Is this clear?
Yes, sir.
Therefore, IRS is equal to I, take common, R1 plus R2 plus R3. I cancelled. So we get a expression for series combination as R1 plus R2 plus R3. So
Why is it called equivalent voltage?
equivalent
Voltage, like the V.
equivalent potential difference, not voltage.
But it is not equal.
Equivalent to all this, sum of this.
Okay.
It is equal. Has to be,
Okay.
otherwise it will not obey certain laws. This potential is split into three parts in series. The potential difference of battery or cell gets dropped, which we call potential drop. V1 is the potential drop, V2 is the potential drop, V3 is the potential drop. But sum of the potential drop should be the potential difference supplied by the cell. Is this clear?
Yes, sir.
We are not going to learn uh, grouping of cells, right? Grouping of cells, if we connect the cells in series, right? If three cells are connected in series and all are 3 volts, that becomes 9 volt battery. Khatam ka. Have you understood this part?
Yes, sir.
Okay. Now, what did we get? We got for series the formula is we got the formula. Now I'm not going to make the cells. I'm just drawing it. Say this point is A, this point is B, right? So R equivalent between A and B, they are all in series. So RS is equal to R1 plus R2 plus R3. Clear?
Yeah.
Okay. Now I'm making some things. What will be the RS?
R5 plus R4 plus R9.
Arey yaar,
Okay,
tell me the
like that.
value.
5 plus 4 plus 9, so it's 18.
Which is the highest resistance in this connection?
9.
Highest resistor. These are all in ohms. Eh? What is the highest resistor?
9.
9 ohm, 18 ohm. Okay, I'm making another. What will be the RS?
100 ohm.
And what is the highest resistor?
60 ohm.
Clear?
Yeah.
So combinations properties. In series combination, the equivalent resistance, we also call it equivalent. Equivalent resistance is higher than the highest resistor present or connected in the circuit. Is it okay?
Yes.
You can make any combination. You will find, arey yaar, it is getting so added up. So definitely the total quantity will be greater than the greatest one. Na? Simple.
Yes, sir.
It's simple mathematics, nothing else. Okay. Now, second question. Suppose I have resistances. Now I am not giving numerical values. I am saying R. All are R. N such resistances connected. Resistors connected. What will be RS?
N times R.
N times R. Good. If N resistors, N equal resistors. N equal resistors, resistors are connected in series, then RS is equal to, suppose all these are R, N times R. Clear? And third, we have seen in series combination, current I, current flowing through each resistor is same. Beta, it is not given in Lakshmi Singh. I don't think. Yeah, I know. I knew it. In class 12, again, we will be studying with some more properties. I'll not, since I have decided I will not go much out of the syllabus. Only crispy points. Done? Understood?
Yes, sir.
You don't need to write all this. This was so written to make you understand about point number one. Noted?
Yeah.
Okay. Now let's go for parallel then. In series, what thing splits up? The potential difference. Am I right?
Yes.
So, in order to derive the formula for series combination, I have to use V is equal to V1 plus V2 plus V3. And I have to just remember the circuit. Clear?
Yes, sir.
Okay. Parallel combination. Parallel combination. See, generally we say if one terminal is at V, the other terminal is at 0. That is why the potential difference is V minus 0 is equal to V. Clear?
Yeah.
Now what is splitting up here? Because if V is here, nothing, no resistances are here, right? These we are assuming that these have no resistances. Though connecting wire will have some resistance, but we are taking an ideal condition that these connecting wires don't have any resistance, right? So the potential at this point will be V, and the potential at this point will be 0. Potential at this point will be V, potential at this point will be 0, potential at this point will be V, potential at this point will be 0. Clear? That means potential is not getting splitted. Yes, madam.
I didn't get it.
Huh?
Can you explain that again?
Beta, if what is potential difference? What is potential difference?
Voltage.
Potential at one point minus potential at second point. Clear?
Yeah.
In a cell, positive is said to be at high potential and negative is said to be at low potential. Right?
Yes.
Now this cell is giving some potential difference. See, without potential difference, current will not flow, na?
No.
Okay. Now this cell is giving V potential difference. Now if I I'm assuming that positive terminal is at a potential 0 V, negative terminal will be at 0 or not? Because V minus 0 is what? V. Clear?
So, like the voltage of the cell is V.
Yeah. Don't use the word voltage. You have used it 3-4 times. Voltage is used by the mysteries. Don't use the word voltage at all. Voltage comes when alternating current comes into picture, which we are not going to study this year. So here the potential of positive terminal is V, the potential of negative terminal is 0, assumed. That is why this cell is giving a potential difference of V. Am I right?
Yes.
Now tell me, if this has no resistance, this potential will reach here or not? Potential drops where? In series we have seen, na? If there is a resistance in between, then the potential will drop by some quantity.
Yeah.
But here there is nothing. So it will be V0 here, V0 here, V0 here. That means the potential difference across all the three resistors, that is R1, R2, R3, is same.
So, like the part which is connected to the negative terminal, they all will have a 0.
Zero potential.
Okay.
The part of the resistor, if you call it head of the resistor, all the three heads are connected to the negative potential or zero potential. And if I call it tail, all the three tails of R1, R2, R3 are connected with V potential. Clear?
Yes.
That means V is not splitting. Is it splitting?
No.
Then something has to split. Now the current I goes like this. Current I will flow or not?
Yeah, it is splitting into 3.
Yes, this will become I1. This will become I2. this will become I3. Clear?
Yeah.
Okay. Now, this I is I1, I2, and I3, na?
Yes.
So, beta, can I write I is equal to I1 plus I2 plus I3?
Yeah.
This current is splitting, I current is splitting into three parts. Clear?
Yes.
Now, using Ohm's law, V is equal to what?
IR. So I
V,
is
V is
V
equal to
by R.
IR. So, I is equal to what?
V by R.
V by R. So, here I can write V by R1 or not,
Yes.
because potential is same. And here I can write V by R2 or not.
Yeah.
And here I can write V by R3.
Yes, sir.
Now suppose I am making a circuit, small circuit, and I am naming this resistance as RP and connecting the same battery to it. So I current flows or not.
Yeah.
For this, can I write I is equal to V upon RP or not?
Yes.
तो खत्म हो तो गया. V common, V upon RP is equal to V common 1 upon R1 plus 1 upon R2 plus 1 upon R3. V cancelled. So 1 upon RP is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. See how we will be doing these questions. Suppose we have one resistance, 2 ohm. Second resistance is 4 ohm. Third resistance is 6 ohm or 8 ohm. So what will be the equivalent resistance? Since these are in parallel, right? Yes, Gauri,
Yes, sir.
can you calculate 1 upon Rp will be equal to 1 upon 2 plus 1 upon 4
711.
plus 1 upon 8. 1 upon R is equal to 4 upon 8 plus 2 upon 8 plus 1 upon 8. So this will be 1 upon R is equal to 7 upon 8. Clear? R
Yeah.
will be 8 by 7. What will be the value of 8 by 7? It will be 1.1. No. 7 ones are 7. 7 ones are 7. 7 fours are 28. 1.14. Okay. 8 by 7 is how much? 1.14 or something else?
1.1.
Can you see? This is less than this or not?
Yeah.
That means in parallel combination, equivalent resistance is less than the least resistance connected in the circuit. N resistance is connected in parallel. What will be the equivalent resistance? Tell me.
N
Take
into 1 by R.
no, no. It will be R by N. Check. अरे 1 upon Rs is equal to 1 upon R into N times. So N by R. But that is 1 upon R, 1 upon Rp. Rp will be R by N or not?
Yes. Okay.
अरे 1 upon R plus 1 upon R plus 1 upon R. This is 1 upon Rp. N times. So it will be 1 upon Rp is equal to N by R. So Rp will be R upon N. Why I am teaching you all this, you know? You will find it very useful. Suppose a complicated circuit is given and there are many places two equal resistances are connected in parallel. Just make them half. Array yaar. If this n is 2, it will be R by 2 or not.
Yes.
3 resistance connected, R by 3. Clear?
Yes, sir.
Now, have you noted?
Yes.
Question. In the adjoining circuit diagram, now let me draw the circuit diagram first. Diagram. Find a total resistance of circuit. B, total current flowing through the circuit. C, the potential difference across the resistor R1. Beta, how to do this? Yeah, Gauri, tell me. Gauri, are you there?
Yes, sir.
How would you do this? I mean, first part. Let's go part by part. First part
This is a parallel one.
is connected in series with the R1. So calculate R2, R3 in parallel, right? What will be the value of R2 and R3? See, I am doing this question. Wait. For this section only, I'll take first this section only. So 1 upon R is equal to 1 upon R2 plus 1 upon R3. Is it okay?
Yes.
So it is 1 upon 8 plus 1 upon 12.
Yes. So
So
24.
24 is the LCM.
3 plus 2.
3 plus 2. That is 5 by 24. 1 upon R.
So R is 6.25.
So let's name this as R dash. Is 24 by 5. So it will be 4.8 or not?
Yes.
Now make another circuit. Now I know the total resistance of this. Okay.
Yeah.
So can I write 4.8 here and 7.2 here it is given?
So total resistance is 12.
And therefore R equivalent is 7.2 plus 4.8, that is 12 ohm. Done. Now total current. This is the total current, no?
Yeah.
So I is equal to what? V by total
V.
resistance.
Yes.
So I is equal to
6 by
voltage is
12.
V 12, that is 0.5 ampere. Correct?
Yeah.
Now 0.5 is passing through this or not?
Yes.
So what will be the potential difference across R1? V1 will be I into R1 or not?
Yeah.
So 7.2 multiplied by 0, ulta ho gaya yaar, sorry. I is 0.5, na? I is 0.5 multiplied by 7.2 or not?
Yes. 7.2 multiplied by 0.5 is 0.5. 7.2 multiplied by 7.2 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 is 0.5. 7.2 mul
which is half
3.60.
3.6. Done.
Yes.
Okay, let's practice few combination circuits. Okay, I do have some. I'm sending it in WhatsApp now. Otherwise, I'll have to download from internet. Hmm. Single card to single to no puro keypad चाहिए सही है ओरिजिनल জিনিস দেবে তো Gauri done?
So 1 second.
আজ হবে না, কাল প্রবাবলি, আর যদি খুব হয় তাহলে মন্ডে আসবে না,
আজ হবে না, মন্ডেই ধরো।
মন্ডে নয়।
না, এটা কি টোটাল 1200 বললেই কি আমাকে সব খরচা খরচা মিলিয়ে তো অরিজিনাল মাল লাগাবে তো?
হ্যাঁ, অরিজিনাল মাল, তাই জন্য
কিন্তু তুই তো অ্যাপে ডেকেছিস, অ্যাপে তো তোর পে করা হবে তো,
হাতে পে করা হবে।
তাহলে খরচাটা তো
ওটা খরচা দিচ্ছি, ওটা তো এমনিও লাগতো অন্য।
এমনি কত লাগবে যদি অ্যাপে তুলতে করা তো?
1999 এটাতে প্লাস অ্যাপের যা
সার্ভিস চার্জ কত নয়, 299?
260
তো টোটাল পে করেছি কত আমরা করছি
আমরা এখন টোটাল পে করছি 1200 প্লাস 260।
দ্যাট ইজ 1469 ইনক্লুসিভ অফ অল অরিজিন। হ্যাঁ,
কম্পারেটিভলি একটু কম, 800 টাকা।
হ্যাঁ, ইউসি কোনো ওয়ারেন্টি দেয় না?
কিছু যায় আছে হ্যাঁ,
আমার মোবাইলটা দে, আমি তোকে 1200 টাকা পাঠিয়ে
তারপরে এর সাথে কথা তো হচ্ছে না।
না, এর সাথে আজকে কথা বললাম, বুঝলে তো, ক্লাসের মাঝখানেই কথা বললাম।
কি বললো?
তো
কেমন
ওর ইসিজি তে প্রবলেম বেরিয়েছে। বেটার গো ফর দ্যাট, check the EMI. I think it would not be more than 800.
কি আমি পাবো
হ্যাঁ,
আর মধ্যে মেশিনটা নেবো বলছো, সেটাই তো লাগছে।
8,000 টাকা চাই।
তাহলে আজকে পেমেন্ট করে দিচ্ছি, ক্রেডিট কার্ডে পেমেন্ট করে দিচ্ছি, তারপরে কনভার্ট করে দিচ্ছি ক্রেডিট কার্ডের উপরই।
ওটা আমি পেমেন্ট করে দেবো। দাঁড়া,
বুঝতে পারছি না ভালো।
তোকে আমি আজকে মালার মাইনে পাঠিয়েছি।
নিয়ে আনিয়েছি, একটু দিয়ে দেওয়া না এটা দেখো, এটা তো হয়।
Gauri, give me a minute. I'm transferring money to my son. Seems to be okay. Wait a minute. Let me check the answer. Gauri, I'm sending you another question. Wait. Beta, give me 1 minute. Gauri has sent you another question. Have you received it?
Yes, sir. So how do we understand what is the diameter of the circle?
No need. Actually, no need. You think it is required? Not able to do? Shall I do it? Gauri, Gauri, are you there?
Yes, sir. So
Shall I
like
do it?
if the value which is making the resistance is combination 4 is not given, like whether it is 1 and 3 or it is 2 and 2, how do I know that?
Suppose this is a wire. Clear? Length of wire is L and the resistance is given 4R. Is this a question?
Yeah, and there's a circle.
Then they have changed into bent into in a circle. Right?
Yes.
Now what will be the, suppose this is A and this is B, right? And this point is P and this point is Q. This is the center. There is no connection. Electrical connection is not there. Now this
It
is the
will be 2
semicircle or
hours.
not? Yes, the resistance of this will be 2R and the resistance in this will be 2R. Now always, I'm giving you a shortcut or a trick. Always connect a battery across which the equivalent resistance is asked across the points. So it is asked across the diameter.
Yeah.
Now doesn't it look like this? If I have to change at all, doesn't it look like this?
Yes.
2R and 2R in parallel. So R
So
parallel will be R by N here. So it
so
will
the
be 2R by
resistance
2. Ah, they have asked
so
the
resistance across AB will become R.
R, R by N.
Okay.
I told you, na?
Yeah.
Clear?
Yes.
Okay. I'm sending you another question. Wait. A very little part of this chapter is left. I'm not putting question numbers. Next day, if I will try to keep 4 or 5 questions, good questions ready. I am giving you the questions which you can do. Beta, always try to draw the diagram. If you are not drawing the diagram, then you are gone. And draw a cell.
So can we like change the circuit?
Change means
Because I'm getting 1 ohm,
you are
like
getting
because
1 ohm
they're
means
set in parallel, no, like two pairs are set in parallel.
beta, read the question properly. Have you made the diagram? ABCD
Yes.
naming. Have
Yeah.
you named it ABCD?
Yes.
Send me whatever you have done. First of all, it is 2 ohms, no?
4 ohms.
Is it 4 ohms?
Like 4 resistances are there.
Hmm. It has 4 resistance, 2 ohm each are joined end to end to form a square ABCD. It is not 4 ohm, 4 resistance of 2 ohms each. Let me show you. Are you looking at the board?
Yes.
The first mistake you made that you didn't read the question. First of all, these are all 2 ohms. Now what it is asking, yeah, tell me, Gauri.
Calculate the equivalent resistance of the combination between any two adjacent corners.
So adjacent corners will be this. Can we take
Yeah.
connect a battery here? Okay. Now V and 0. That means this is at V and this is at 0 or not.
Yes.
Now the current will flow I1 will go here, I2 will travel like this, right? And here I2 and I1 again will become I. Am I right?
Yeah.
If the current is same, that is the part A, B, C, D. From A to B, B to C, C to D. Current is same or not? Yeah, Gauri, tell
Yeah.
me. That means these resistances are in series or not?
Yes.
Now, can I draw an equivalent diagram again? No problem. I will draw it again. Three resistances are between V and 0. Clear?
Yes.
Now, one more resistance is left between V and 0. This is the simplified diagram for this. Is it okay?
Yes, sir.
2, 2,
So
2.
RS can become 6
That means
ohms.
2 by 3, sorry, 6. Yeah, we can draw again. It is 6 and 2. right? Remember the shortcut Rp is equal to R1 R2 divided by R1 plus R2. So 12 by 8, 3 by 4, that is 0.75. Done. Are you understanding the concept?
Yes, sir.
So this is your A. If I start, if I have to start, this was A, this was B, this was C, and this point was D. Khatam. Are you getting my point?
Yes, sir.
So till the time you don't follow my instructions, you will be in soup. I'm telling you. Gauri, this is I'm giving for practice, and you very well know what will happen in test. Gauri got scared. There are many methods, beta. We are just understanding the basics. Okay. Can we call it a day now?
Okay.
Type in the group to start with. Domestic electric circuits. Followed by power and power rating.
The power and
Power rating. Shall I end the meeting, beta?
okay.
Bye.
Thank you,
See you
sir.
on Tuesday. Acha. Tuesday we will be having our class at normal timing, na? 4:30.
Yeah.
You have a school on Tuesday. Am I right?
Yes.
Okay. Ending the meeting now.
Thank you, sir.
Bye. Bye. Bye.